As a young citizen of India, armed with technology, knowledge, and love for my nation, with a vision of transforming India into a developed nation, I'm joining Shobhit University. What about you?
Very good morning to all the participants from India and abroad. Shobhit Institute of Engineering and Technology, Meerut, a DAC accredited with A grade 12B status deemed to be university, and its Center for Agricultural Informatics and E-Governance Research Studies, Center for Agribusiness and Disaster Management Studies, and Center for Health Informatics and Computing extend greetings to all the participants from India and abroad who are attending today's national webinar series on doubling farmers' income by 2022 and beyond, Atmanirbhar Bharat in agriculture. This webinar is being hosted on every Thursday from 11 a.m. to 1 p.m. Indian Standard Time. Today is the 19th September 2024. It is a very special day. World Food India 2024 starts from today in Delhi with the aim to showcase the country as the food basket of the world, and explore the investment and collaboration opportunities for food processing stakeholders, including food processors, technology and equipment manufacturers and suppliers, logistic players, and cold chain operators, as well as food retailers. And this is with the World Food India 2024. Today's topic is very important. A food value chain from India. Vermiwash contains mucus, excretory products of worms, and various concentration of macro, micro, and beneficial nutrients, along with the beneficial microorganisms, growth hormones, vitamins and enzymes and amino acids. Therefore, is a good source for plant nutrition in sustainable agriculture. And let me welcome today's guest speaker to deliver the talk in the 131st edition of the National Webinars of Series, Dr. Bhagya B. Sharma. Namaste ji. She is the Deputy Director, Center for Environmental Studies, Yenepoya, deemed to be University, Mangaluru. Today's topic is very important. Vermiwash Fertilizer, an organic tonic empowering small and marginal farmers to improve soil health and plant health in their farms. I wish to inform the participants and the guest speaker that the university regularly conducts two webinar series, national webinar series on doubling farmers' income by 2022 and beyond on Thursdays, and international webinar series on open source digital technologies towards self-reliant India on Saturdays. So far, we have conducted 130 webinars on various topics, and each topic can lead to an agri-tech startup. And India has got 6.5 lakh villages, 2.5 lakh gram panchayat. Each gram panchayat can have an agri-tech startup with the involvement of 4,500 engineering colleges and 45,000 non-engineering colleges and 1,500 deemed to be universities in the country. There are many topics, but if I read out all the 130 topics, it will take so much time. But I will, tell some of the very important titles which we have organized. First one was role of agricultural cooperative societies in e-governance, integrated mariculture, aquaponics, and precision agriculture, MAPA biofarms for income revolution, digital agri-tech and industry perspective, weather decision technologies for increasing farming income, big data in smart farming, sustainable soil and land management for climate smart agriculture, role of technologies in mitigating crop risk, and smart tribal farming, health informatics network value chain for value chain of medicinal cash crops and neglected tribal wisdom, smart rainfed farming, integrated technology implementation for agriculture and rural management. Smart tribal farming measures for increasing economic productivity and empowering tribal community in various gram panchayat. Doubling farmers' income, empowering through bioenergy farming, and creating a more nutritious and sustainable food supply. And innovation and research in biomass of their potential utilization. An attempt for the extraction of cellulose and charcoal from biomass and their conversion to some useful products. Smart tribal farming measures for increasing economic productivity and empowering built tribal community in Dungarpur district. Market linkage to farmers through digitalized agri value chain. Village level cooperatives, a proven model to elevate farmers from their poverty. Growth and structural transformation in agriculture in India moving to the next level. Agricultural resources information system and micro level planning for enhancing farm health. Village e-commerce, challenges and barriers and potentials in rural India. Doubling in Indian farmers' income through indigenous cows. Opportunities and challenges. Innovative future farming need for design of agriculture. Food value chains, issues, challenges, and potentials. And smart tribal farming, precision farming through enhanced efficiency fertilizer for increased yields, greater profits, and a higher carbon credit, achieving Sustainable Development Goal 2 and Sustainable Development Goal 13. Digitalization of agricultural systems, pathway for agricultural innovation, and smart farming towards empowering small and marginal farmers in Kadalur district. And today's topic is very important. An organic tonic empowering small and marginal farmers to improve soil health and plant health in their farms. Keywords are biofertilizers, organic tonic, small and marginal farmers empowerment, soil health, plant health, smart rainfed farming, integrated technology, agriculture and rural management. To develop in any sector of economy, a nation essentially needs four main synchronized interventions. One is enabling policy environment, state-of-the-art technologies, financing mechanism, and entrepreneurship capacity. India is an agrarian economy and it's a land of villages. Agriculture is the main source of food, employment, in income to 70 to 80% of the people suffering from hunger in developing countries. At present, agricultural livelihoods are being severely impacted worldwide as a result of anthropogenic global warming and climate change. Farmers of India are facing multidimensional problems, price fluctuation, debt, and lack of infrastructure and weather. Indian farming community comprises of about 14.5 crore operational holdings, of which 85 to 90% of the farmers having small and marginal size operational holdings. They are the food security network for India. Farmer needs timely, location-specific, and personalized information for effective control on their production, risk, and then market their produce to identified market opportunities. According to Dr. Christopher Barrett, who teaches applied economics and management at Cornell University, USA, there are three forms of hunger encompassing half of the world now. Deepening poverty over generations means undernourishment, nutrient deficiencies, and obesity. And also said COVID-19 has exacerbated global hunger, which is also impacted by strife and climate change. Agriculture extension into forest and wetlands have caused 50% of zoonotic diseases among humans recently. Many national level programs, be it Digital India, Make in India, Skill India, Startup India program, have faced operational difficulties for its impact at farm level and farmer level, and that too at small and marginal farmers. That's why we need to have an cooperation and collaboration with all the higher educational institutions in the country to reach the farmer and farm level. We have only one KVK in every district. We have the recommendations from doubling farmers' income by 2022, report 2018, on reforms through digitalization of agriculture systems. I was part of that committee and I chaired 2 volumes, volume 11, which talked about empowering the farmers through extension and knowledge dissemination. Volume 12B, Digital Technology in Agriculture, which talks about 7 mission mode programs for total digitalization of agriculture systems for agriculture transformation. These 7 mission mode programs includes synergization of all government schemes at farm level, village level, through smart irrigated farming, smart rainfed farming, and smart tribal farming. Digitalized agricultural agromet advisories and comprehensive risk management solutions. Digitalized agricultural resources information system and micro level planning to convert a village as a smart village. And digitalized agricultural commodity value chain from farm to table, 400 agriculture commodities, to make farm as a service, that is to make digitalized access to all inputs which the farmer and farm needs for their productivity increase, be it seed, be it fertilizer, be it credit, be it logistic, knowledge, and so on and so forth. Post-harvest management, value addition. Then digitalized integrated land and water management to make more more crops per drop. And then last one is very important, digitalized integrated farm health management. Today this topic is very important. This integrated farm health management talks about farmer health, farm health, public health, which is also looked into human health, allopathy, Ayurveda, Siddha, Unani, homeopathy, and naturopathy. Each one looks into the disease profile different. And we have plant health, and we have animal health, we have soil health, we have water health, we have fish health, and we have environmental health. If the soil is not good, because minerals of the soil controls the metabolism of the cells of human, cells of plant, cells of animal, cells of fish. And if the soil is not healthy, what we eat from the plant cannot be healthy. What we take from the cattle, goat cannot be healthy. What we take from fish is not healthy. This is where to see these 6 forms of health, human health, plant health, animal health, soil health, water health, fish health, and environmental health, is on a village level with a GIS technology. This is where a very important research problem is, including computer science people and biology science systems people, that use of AI, artificial intelligence, blockchain technology, and data analytics to ensure optimal nutrition in soil and harvested food to minimize human disease. This is a very integrated approach, and to see to that, every village is out of any COVID-19 situations. That 80% of the disease which we get come from animal. So this is a decision science, and India can become, international data center with 10,000 data scientists on the health informatics and computing. This is with the AI, artificial intelligence, machine learning, and data analytics and blockchain technology. We have 45,000 primary health centers, equal amount of primary animal health centers. There is no clinical AI. There is no system which helps an MBBS doctor or a veterinary doctor for a disease discovery. This is where the educational institution to bring in a clinical AI and a machine learning between doctor and health informatics. It is a very big potential, and that's why this today's topic is one component: how to bring in a nutritious food and empowering small and marginal farmers without using chemical fertilizer to improve soil health and plant health. This is very important. And Sustainable Development Goals talks about 17 Sustainable Development Goals and Agenda 2030. 2020 and 2030 are the decade of development. And many of the Sustainable Development Goals are not yet to be achieved in many countries. But the step which India has taken for bringing out the digitalization of Indian agriculture system can facilitate achieving many sustainable development goals to the tune of 12 sustainable development goals achieved. This is very important. And even the integrated farm health system is in the order of $1 trillion economy. And we have an agriculture value chain is an integrated range of goods and services necessary for an agriculture product to move from the producer to the final consumer. Value chain is very important. Input suppliers, inputs, land, water, seed, fertilizer, pesticides, farm implements, tractors, and machineries, and farm process, farm production, harvesting, and post-harvesting, and food processing, and then consumers, that's marketing, the hearts and mandis, wholesalers, distributors, and retailers and consumers. Traceability is very important. Blockchain technology is very important. Then only the percentage of retail price can come down to the farmer who produce. Today's topic is Vermiwash Fertilizer, an organic tonic empowering small and marginal farmers. 85 to 90% of the Indian farming community belongs to this sector. That's why this topic is very important. To improve soil health and plant health in their farms, it means that we have to have the digital systems to monitor, and also physical systems on the farm. And in the national webinar series, we conducted about 9 webinars related to these aspects. Octosol organic humic solutions for increasing crop yields and quality while increasing farm income and improving soil health. Closing the nutrient loop, phosphorus management in protein farming, doubling the income of farmers through eco-agri revolution, organic spices cultivation for doubling of farmers' income in northeast region of India, and small acre natural farming, future of farming rooted in Indian culture, agricultural resources information system, and micro-level planning for enhancing farm health. Key to achieving the doubling farmers' income by 2022 agenda put forth. Smart tribal farming, integrated farm health management system for improving food, income, and livelihood security of tribal farmers of Bhagya, Union Territory of Jammu and Kashmir. Organic farming, key to doubling farmers' income. And doubling farmers' income, imperative of plant health informatics network, and organic and natural farming certification and way forward. Despite rapid industrialization, agriculture remains one of the key areas of employment generation in rural India. In view of this fact, Indian budget 2023-24 has tried to revolutionize this sector by encouraging agri startups and natural farming. Agroecological and sustainable agriculture is need of the hour. It is ecological farming is key to a sustainable future. And budget 2023 gives a boost to natural farming, organic farming, and eco farming revolutions are taking place in the country. We also have another technique, Sahuna regenerative technique, a no-till conservation agriculture method of rice-based farming. It is also necessary to quote how to achieve conservation agriculture. And this is some of the methods which are being practiced at the village level. And today's topic is very important, for the, uh, you know, you know, for the farming sector at the grassroots level. The Vermiwash is a natural product that its application is compatible with environmental protection. We'll have a lot from our guest speaker, Dr. Bhagya Sharma. What is its economic importance? Vermiwash contains mucus, excretory products of worms, and various concentration of macro, micro, and beneficial nutrients, along with the beneficial microorganism, growth hormones, vitamins, enzymes, and amino acids. Therefore, is a good source for plant nutrition in sustainable agriculture. Another article which I was able to see in Pharma Innovation Journal, published in 2021, it is a plant growth booster and a disease suppressor. And that's how it is. It's an appropriate topic. It is an organic tonic. It is tonic means, it's a booster, growth booster, and also disease suppressor. It is rich in plant growth hormones, micronutrients, and major nutrients like nitrogen, phosphorus, and potassium. So in this lecture, we will understand related terminologies like compost, vermicompost, vermiculture, and vermiwash, and so on and so forth. And the synopsis of the guest speaker is very enriched, and the synopsis talks about that while the Green Revolution transformed India from a food deficient nation to one that could export food, it also introduced significant environmental issues such as soil and water pollution, biodiversity loss, and health risk due to the excessive use of fertilizer and pesticides. As a result, there is a shift towards organic farming practices that focus on replenishing soil nutrients and promoting environmental health. And is a major concern is the increasing volume of organic waste, especially in urban areas, where about 70% of the municipal soil waste is biodegradable. And this reflects a broader issue. When this waste ends up in landfills, it generates methane, a potent greenhouse gas, and contributes to soil pollution. This reflects a broader issue with a linear economic model characterized by take, make, dispose approach that generates significant waste. It's very important. And in contrast, transitioning to a circular economy allows for the recycling of waste into resources for other processes. And this topic is timely, and let us now turn to the address by Dr. Bhagya Sharma, Deputy Director, Center for Environmental Studies, Yenepoya, University, Mangaluru. Today's topic will motivate and galvanize the participants watching over telecast through facebook.com Shobhit University India, youtube.com/Shobhit University in, or linkedin.com/school Shobhit University to unlock the opportunities to empower small and marginal farmers through improving soil health and plant health in their farms. 90% of the 145 million operational holdings are in small farms. And let me invite Dr. Bhagya Sharma to address this important webinar. Mr. Manish, can we put the profile? Dr. Bhagya Sharma is a dedicated environmentalist with extensive academic and professional experience. She holds an impressive educational background, including PhD in ecological studies from Mangaluru University and a postgraduate diploma in bioethics and medical ethics. Dr. Sharma further enhanced her experience in environmental management at the Indian Institute of Science, Bangalore. As the Deputy Director at the Center for Environmental Studies at Yenepoya University, she has been instrumental in advancing research and education in environmental science since 2010, following a decade of service as Assistant Director. With over 23 years of teaching experience, Dr. Sharma has served at various institutions. She has authored 35 publications in national and international journals and has contributed to several significant books on medicinal plants and the biodiversity of Yenepoya University. Her research interests focus on waste management, vermicomposting, and environmental assessments, reflecting her commitment to sustainable practices. Additionally, she is actively involved in additional editorial and coordination roles, enhancing academic engagement within her university and beyond. Dr. Sharma is deeply committed to fostering environmental awareness among the youth. She has actively conducted various training programs on vermicomposting and delivered engaging lectures and addressing critical environmental issues. Through her efforts, Dr. Sharma aims to inspire the next generation to embrace sustainable practices and contribute positively to environmental conservation. Thank you, madam, and I invite you to deliver your talk in the national webinar series on doubling farmers' income by 2022, Atmanirbhar Bharat in agriculture, on this very important topic, Vermiwash Fertilizer and Organic Tonic, empowering small and marginal farmers to improve soil health and plant health in their farms. Thank you very much. Over to you, madam.
Good morning, all of you. It's a stupendous task to deliver knowledge at a national and international level every week. I would like to congratulate Shobhit University and Moni sir for this initiative, and many thanks for inviting me. Well, to start with, I'll share my presentation.
Thank you. Your voice is not coming. Hello?
Sir, I'm sharing the slide.
Okay.
Is the slide visible?
No, it is empty screen. You just to see that it's not coming. Mr. Manish? Okay. No, you go to the front. Okay. This is the first slide? No. It is green revolution is coming. Mr. Manish?
Slide 1 is not visible.
It's not visible, madam.
It's okay. Then we will start with the second slide. No issues.
No, first slide is also more important. No?
Should I try again?
Okay, yeah. Why it is not coming through? No. You have to go to the file and
Done, sir.
okay. Okay, I think it's not coming through.
First slide is not coming. You start. You please start.
Okay. Yeah, we will start. So again, good morning, all of you. And in the recent past, we all have seen that there is a lot of interest in organic agriculture and sustainable farming for the production of crops. But as you all know, the backbone of Indian economy is our agriculture. But this was not the case in 1960s and 70s when we were facing a lot of food shortage because we had the issues of growing population. We were also importing food from other countries. In addition to this, we also had to face the challenges of malnutrition, hunger, poverty. So it was time then to revolutionize the agriculture and make it more efficient and profitable. And because of that, we had the Green Revolution. Green Revolution focused on high yielding variety of crops, the irrigation facilities, use of inorganic fertilizers, pesticides, also mechanized the farm tools. It also provided credit for the farmers. But was the Green Revolution sustainable? Today we can say that it's no, because we only concentrated on the profit and we forgot or we neglected the other two aspects of sustainability, that is the people and the planet. And hence we are looking into other alternatives so that we can replenish the soil, we can get back the health of the farmers, we can also get back the health of the environment. And therefore there is a growing interest in organic farming, where we can reduce the negative impacts which we got through the Green Revolution. Green Revolution shifted India from a starving country to a place where we started exporting food. But we had soil pollution, we had water pollution, the nutrients of the soil were lost, the biodiversity of the soil was lost, and because of the irrigation facilities which developed aggressively, the water level also decreased, and the use of chemicals aggravated even to or added up to the climate change which was already in the process. People believed that the traditional system which we were practicing, that is organic farming, it would help to replenish the soil, reclaim the activities of the soil in a very fertile way, and take care of all the properties. It would help also to get back the biota, the soil biota, and also take care of the farmers' health as well as the health of the environment. Before we could go to the vermicomposting directly, I would also like to say the issues which we are currently facing because of the growing population. Whether it is agricultural waste or mainly it's the organic waste production, which has increased nowadays because of the increasing population. We are not able to manage it. There are different types of organic waste which is inappropriately disposed because of the lack of awareness or the lack of management of this biodegradable waste. And also because of the industrial revolution, ever since that, we have been following the linear economic fashion where it is the take, make, dispose. We withdraw the raw materials from the environment, make a product out of it, and ultimately dump it. The waste which is being generated has increased over the years because of this type of system, the model which we are following, the linear economy. Therefore, to change this or to address the root cause of the linear economy, the only possible solution is to shift to a circular economy. Circular economy is a model where the waste which is generated from one method will be used for the generation of some product, and it will be extended or it will be the resource for the some other processes. Okay. And today in this presentation, I will be trying to give you the potential of vermicompost and vermiwash as a sustainable strategy, and also highlighting the benefits of vermicompost and vermiwash for the farmers, for the soil, and for the environment. So the solution which we will be discussing today is again a technology based. It is vermitechnology. Vermitechnology is a process where we are using earthworms which help in the conversion of the organic waste into value added products, which we call as vermicast or the vermicompost. This is a very eco-friendly process. It is also an economically viable process and socially acceptable process, very easy to be followed. And the heart of this technology are our earthworms. They are called as the environmental engineers because their experience is too vast. Almost 600 million years of experience they has as ecosystem engineers. So this technology has helped us find a solution to help minimize the environmental effects of the organic waste and also get back the fertile soil, which is very essential for our agriculture. There are various components which are involved in vermitechnology. If I have to briefly classify them, we have vermicomposting, the process where we convert the organic waste into vermicompost using earthworms. And the second one is vermiculture, where it is only the propagation or breeding of the earthworms in a very short duration of time by giving it a very conducive environment. And the third is the topic for today, that is the Vermiwash, liquid organic fertilizer, which is generated using earthworms and vermicompost, which is said to be a very nutritive tonic. It's an organic tonic, very, very powerful and useful for the farmers. As I mentioned, the heart of this technology are the earthworms. Briefly, just giving an introduction to it, the earthworms, as I mentioned earlier, is a very old species which has been doing a lot of work for the soil. And Aristotle called it as the intestine of the earth. They are very important invertebrates. It is not just the earthworms in the soil. There are various other microorganisms. You have a lot of detritivores, saprophages. All these organisms, they bring about a great impact on the soil. They bring about physical changes, chemical changes, and biological changes. And so they are called as the ecosystem engineers. As you can see in the chart, they bring about changes in the physical properties of the soil, the porosity, the water holding capacity. They increase the organic content of the soil, humus, which is where the humic acid formation takes place. They also help in protecting the plants by increasing their immunity, by suppressing the soil-borne pathogens, and they are very important also in nutrient cycling. These earthworms, they create a very conducive environment, very comfortable environment for all the soil organisms to live and survive, as well as all these together, they support the plants and help them thrive in this particular environment. There are various processes in which the earthworms can be used. They are used as waste engineers, conversion. I'll not go to the details. They can be used in wastewater treatment. They can also be used in as a biochemical engineer, where bioremediation. They can even convert the toxins which are there in the soil. They can also be remediated using earthworms. And today we will be seeing the importance of earthworms in agriculture, which is known most of the people, like how earthworms are helpful. They are called as farmers' friends, and how they will help the soil in reclamation and help the plants. Briefly, this is the life cycle of one of the species, that is Udrilus eugenie is the name of a species. The earthworm, also called as the African night crawler. The life cycle almost takes around 55 to 70 days. It also depends upon the climatic conditions, the availability of nutrients, all influence the life cycle. You can see the cocoons here. These are the earthworm cocoons. Earthworms are hermaphrodites, that is, they have the both male and female reproductive organs, but they do not carry on self-fertilization. The two different earthworms, when they copulate, they will be exchanging the spermatocytes, or the spermatozoa will be transferred to the other earthworm, and that results after the copulation process. You will see the formation within 5 to 10 days, the formation of the cocoon, where the ovaries also get matured and these eggs or the cocoons are formed. It contains the eggs and the sperms, where external fertilization takes place within the cocoon. And after 12 to 21 days, the cocoons are hatched, and you have the juveniles coming out of the cocoons. Almost 4 to 6 juveniles per cocoon will be released. And these hatchlings will undergo a growth phase. They are not yet matured, so they will, for almost 40 to 45 days, they will take a growth phase and you will get an adult earthworm by around 40-45 days. Now this will develop something called a clitellum, and this adult earthworm is now ready for reproductive phase, and it will continue with the copulation process. So this whole process will take up around 55 to 70 days. So this is briefly about the earthworms, how they are important and what is their life cycle. There are different types of earthworms which are used in composting. We have Icenia fetida, we have Perionex and Eutrylus eugenie. These are most commonly called as the compost earthworms, which are used because they are very effective in conversion of organic waste into the vermicompost. So the compost which is generated because of the earthworms by the conversion of the organic material, the process is a bio-oxidative process where the decomposition takes place. There are a lot of microorganisms in the soil. There are mesophilic bacteria which assist the earthworms in this process, and through the biochemical reactions, the microorganisms and the earthworms, they will convert the organic compost into very fine particles which is excreted through the earthworms in the form of vermicast. When we look into the earthworm, the intestine or the gut of the earthworm, it is also called as the microbial factory, because there are a huge number of microorganisms within the earthworms which are also excreted along with the organic waste which is being converted into the vermicast. The vermicast which is generated is very rich in nutrients. It contains macro and micronutrients. It also contains the phytohormones, that is the plant hormones, auxins, gibberellins, indolestic acid, the humic substances which are also produced, which is because of the decomposition process, the black color of the soil, what you all can see, which is helpful for increasing the fertility of the soil. It also helps in water retention of the soil. There are different types of earthworms. You have the epigeic earthworms, that means the worms which are on the surface of the soil. They feed on the litter which is available and they are found on the surface. You have the aniseic soil earthworms. They are found slightly below, where you can see them forming burrows. The vertical burrows which are formed within the soil, they are very, very helpful because they increase the porosity of the soil. They help in aeration. They also help in the permeability of water. This also helps in the growth of plants. The roots can penetrate easier. And as I mentioned earlier, the gut of the earthworms is very rich in microorganisms. So the vermicast, along with the nutrients, it is also very rich in microorganisms. And these microorganisms include like Azotobacter, or in general, if I have to say, they are the nitrogen digesting enzymes and the nitrosomonas and the phosphate solubilizers. In combination, the earthworms along with these microorganisms, they decompose the organic waste, and the nutrients are made available to the plants in such a way that it is easily absorbed by the plants. The bioavailability of the nutrients for the plants is faster or higher compared to any other chemical fertilizers. So this improves the quality of the soil. And when we talk about the biodiversity of the soil, the vermicompost contains the microorganisms which is almost 100 times more than what is available in the soil. So the vermicast maintains all the components which is essential to have the soil fertile. The pH will be maintained, and the vermicomposting process, as I mentioned earlier, is an eco-friendly process. When the organic waste is dumped in a landfill, it releases methane, which is a potent greenhouse gas. But the vermicomposting process is an eco-friendly process which does not release any greenhouse gases. So in that way, it is very helpful for the environment. You will also have a pH which is maintained from 6.5 to 7.5. Moisture content will be around 60 to 80%. So microorganisms are found. You also have the macronutrients and micronutrients, organic content, carbon content. So a wholesome food, or a complete package of all what is required by the soil and the plants, is available in the vermicompost. Coming to the methodology, how you can prepare the vermicompost, depending upon the economy, that is availability of the land and also the money. You have different methods. There are bed method, there is a heap method, tank or bin method, uh, and also the availability of land in the sense that you need to have a shady cover. The bed cannot be exposed to sunlight, and therefore it is essential that it has to be covered. It should also be taken care that's in the bed method. You'll also have pits which will be made underground, and it will be covered by the gunny bags or heap of organic matter on top. This is another method, a very simple method of covering the organic matter and releasing the earthworms, and again covering with the animal dung mainly. There are different types of dung which can be utilized here, but the cow dung is the most beneficial, which is very rich in microorganisms. And the process of vermicomposting usually takes place in two stages. Earthworms feed on partially digested food, so you need to have a digested organic material which is brought about by the microorganisms. And the source of microorganisms for that decomposition is the cow dung. So the organic matter mixed with cow dung brings about the preliminary decomposition process, and which is fed by the earthworms, and they convert it into that valuable. Most of them even call it as a black gold because it contains all those nutrients. So these are the various methods, and to give you a general value like how a tank method can be done, it is 2 feet height. You can be using 2 to 3 feet. The width of around 3 feet also can be used. The length of the tank depends upon the availability of the land. Up to 10 feet or 20 feet the length can be taken. There are also other methods where twin tank methods are done. You can see here the twin tank methods, or even 4 tank methods are done, which will be helpful for the movement of the earthworms from one tank to another tank. I will not go to the more details of this composting. I will explain to you what we do at Yenepoya University. So this is the vermicomposting unit we have at Yenepoya University, which was started in 2014. We have 6 tanks here. You can see each tank, you have aeration facilities and covered by mesh on top. So each tank has a capacity of around 450 kg, and we are having various type of raw materials which is available in the campus, which we are using here. And as I mentioned earlier, there is a pre-digestion process for the composting where we have to process the raw material. Do not add the material directly to the earthworms. So we have a shredder here. You can see where the garden waste is shredded. As you reduce the size to almost like 5 centimeter, it increases the surface area for the decomposition and fastens the process of the composting. We also have these grow bags in addition to the tanks where we decompose the material using the cow dung slurry. This is, you can see, as a mesh composting where within the garden, the leaves which are collected, they will put into this. We are also adding some vermiwash into this, and that decomposes the material in the garden. And to a certain extent, little bit of shredded paper also will be utilized. So this process fastens the vermicomposting process. So this is a continuous process which we do. One of the problems which we faced initially, or the people who are composting also told us that it is a very long process. It will take more than 2 months to get the vermicompost. So this is one of the solutions which we found, where on a regular basis, if this decomposition has been done, so when you harvest a tank for vermicompost, it is now readily available for the pre-digested organic matter which can be added into the tank. And these are the other raw materials. We have a central kitchen where almost 30 to 35,000 meals per day is cooked. So we have a huge quantity of vegetable waste which is generated, and the fruit waste and the vegetable waste, they are also chopped into small pieces just to facilitate the process of decomposition. The coconut coir is also used, and as I mentioned earlier, the cow dung. We have a slurry tank, as we cannot use the fresh cow dung. We collect the cow dung, we prepare a slurry, and it will be stored in this tank, and which will be used as and when we require. So these are the raw materials which are used in the vermicomposting process, and a little bit of processing will help in fastening the process of decomposition. And as you can see here, the process within the tanks, at the bottom of the tank, we have the coconut sheath, which has been forming the bottommost layer. Then we have the garden waste and the vegetable waste, which are added layer by layer, and they are also mixed with the cow dung. The cow dung slurry is added after every layer. This was the initial step where I mentioned where we are not doing the pre-digestion. So the primary decomposition is to take place in the tank, and after 1 month, when these are partially digested, the earthworms were being introduced. But now, as I mentioned, we are decomposing this on a daily basis. So from a tank, when we harvest the compost, the partially digested organic matter will be added into the tank, and then the earthworm will be introduced into it immediately. There are certain precautions also which has to be taken here. As you can see here, we have this mesh which helps to protect the earthworms because they have natural predators. There are rats and the birds and the termites which can feed on them. So this mesh will help in protecting the earthworms. And we also have a roof on top of this which will prevent the direct sunlight, and also there is no exposure to the rainfall. The water will not penetrate into any of the vermicomposting units. So these are the raw materials processing. And as I told you earlier, after the decomposition, it may take around 25 to 30 days. Okay, the earthworms will be introduced, and these earthworms will then bring about the secondary decomposition process, and again, which may take around 2 to 3 weeks. After which we will be harvesting the compost, and this compost will contain the earthworms. There are different methods how you can harvest and you can collect the earthworms. What we do is we will be sieving it, and the compost will be collected, and the earthworms will be put back into the vermicompost tanks. In the field, when the farmers are preparing the vermicompost, okay, as I showed you earlier, the twin tank method or the 4 tank method, there are simple methods where before harvesting you have to stop watering the moisture content when it decreases, and in the tank only at one corner, when you put either the cow dung or maintain the moisture content, all the earthworms will move to that particular area, and the remaining part, the compost, can be collected. But there are farmers who also have these sieve units where the compost will be added to it, they will sieve it, and the earthworms will be collected and put back into the tank. So depending upon the process which the farmers are comfortable, they can have different collection methods. And for a 10 feet tank, they can use up to 1 to 2 kg of earthworms. It is very essential to see to it that the organic content is maintained in the tanks, because the earthworms are voracious feeders. They require a lot of organic matter, and they almost eat equivalent to their body weight. So if there is no availability of food, they will again move away from that place. So you have to see to it that enough food is available, and also not add too many earthworms into the tank, because that will also immediately decrease the organic content. The competition will increase. Various other factors which you have to take care is maintain the pH, maintain the moisture content. When it comes to the farmers, they will be using only the agricultural crops for the vermicomposting. Since we are in a academic institute, we are getting the waste from the kitchen. We have to take care that we do not add citrus fruits, do not add garlic, onion, and all, because that will alter the pH of the composting process. And also take care not to add any plastic. So all that has to be hand picked. We have laborers who have been trained for it, and they take care, moisturing and the watering the system, maintaining the moisture content. All these will be taken care. Earthworms are very sensitive. They are very shy. They do not, you cannot see them on the surface. They'll always be burrowed deep inside. They like dark atmosphere, and they need a lot of food. And only when the organic content is available in large content, even the reproduction takes place well. When you are adding like 2 kg of earthworms, by 30-40 days, if enough organic content is there, if all the conditions are maintained ideally, you can almost see that the earthworms get doubled. That doubling of the earthworms also happens only when there is availability of organic content and conditions are ideal. So these earthworms can also be used as a subsidiary source of incomes by the farmer, where the compost can be sold and also earthworms are sold. Around a kg of earthworms cost around 500 rupees, so which is also a subsidiary source of income for the farmers. And the capacity of our tank, as I mentioned, was 450 kg. Almost 300 kg of compost we harvest from every unit. Earthworms have the capacity to reduce the solid waste volume by 40 to 60%. They do not release any greenhouse gases. The organic waste management can be done. They also increase the fertility of the compost. They add microorganisms and the phytohormones, which usually will not be found in any other compost. Phytohormones can be found in the vermicompost, which is a very, very important ingredient for the plants to grow. Another component here is vermiculture. There is also a method where only earthworms are cultured and they are sold for the farmers. And earthworms are also very important food for fishes, for poultry, so it can be sold as a subsidiary income there also, and which will not require a huge space. Vermicomposting will require a huge space, but vermiculture can be done in a small unit. So with this, we will move on to vermiwash, but this is the vermicomposting unit which we had in our campus. Vermiwash is a nutritive organic liquid which is produced from vermicompost. For preparation, there are various methods of preparation of vermiwash. Usually, you will have a barrel like this, which is almost like 200-liter capacity barrels will be used. And the most preferred is the plastic or a concrete one, usually a circular one, so that the pressure can be uniformly maintained. There are various methods of vermiwash production. You have the heat stress method, you have the cold stress method. There, for a small scale, you can see that the earthworms can be added into, in the heat stress method, they will be added into a container where you have lukewarm water, maybe around 35 to 40 degrees Celsius. So when they are treated in this way, the earthworms release the mucus content, the coelomic fluid from the earthworms will be released into the water, which is very nutritive. The mucus, the excretory products which is released into that water will be retained. The earthworms will be again shifted from this warm water to the room temperature water, and again further they will be stirred and all the nutrients will be collected. In a little bit larger scale, they can be done in a tub mixed with the water. All the nutrients will be released into that water. After that, the earthworms can be collected and put back into the vermicomposting unit. So this liquid is very rich in the nutrients, which contains the mucus, the enzymes, which is coming out from the earthworms. This is called as a heat stress method, but you cannot do it in a large scale. Same process is also done by cold stress method, where the earthworms will be put into a tub with water containing ice cubes. The same process will take place. They are the two different methods how vermiwash can be collected. But when you have to do it in a large scale, you need to have tanks like this or a barrel. Now, if I'm going to say this, which is around 200-liter barrel, the steps within this is here there is a schematic representation how the contents are within the barrel. At the bottom, you will usually have the pebbles or the bricks for around half a feet within the barrel or the tank where the vermiwash has to be prepared. Some of them also insert a bucket inverted down in this process so that you get a clear liquid, or else there will be a mixture of all other contents. So to prevent that, inverted bucket can also be placed in this layer. So the bottommost layer, you will have the pebbles and the bricks, above which you will have again around half a feet of the sand, which helps in the filtration process. This will be followed by adding the partially digested organic matter, the vermicompost or the partially digested organic matter, along with the earthworms. will be placed above this. In a 200-liter tank, almost up to 150 kg of organic waste can be added. And for every 100 kg of organic waste, around 5 kg of earthworms can be introduced. This will be again laid over by cow dung. Again, there are different processes. Some of them again add vermicompost. They can also add some of the organic matter and the cow dung, and then cover it with a gunny bag. Before introducing the earthworms, this whole setup has to be left as it is by watering, and see to it that the water comes out of the tap which is connected at the bottom. The whole setup is left as it is at least for 2 to 3 days. It is just to get it set up within the tank. After 3 days, the earthworms, just like I told you, for 100 kg, 5 kg of earthworms can be introduced into this tank. Now, when the earthworms are again introduced, moisture content is already there. So, do not disturb it or do not add water again for 2 to 3 days. Allow the earthworms to get acclimatized to that condition and let them go and start the decomposition process. And after again 2 or 3 days, water has to be added. On a daily basis, around 5 liters of water can be added, but it has to be added trickling. It should not be poured continuously at one time. Usually there will be a vessel which is placed above this tank, and the water will be dripped slowly throughout the day to this vermiwash unit, and the water trickles down through all this. It will trickle down through the organic compound, it will go through the cow dung, the earthworm, because the mucus material, everything, all the nutrients what is there in this whole heap will be slowly absorbed by the water. It slowly filters down and goes and gets settled at the bottom of the vermiwash tank. And this in a day, like from morning till evening, if the water is added around 5 liters, in the evening, by the end of the day, you may collect around 2 to 3 liters of vermiwash. So this can be collected maybe after 5 days or 6 days after setting up the tank, and that liquid is the vermiwash. This is the proper way of preparing of vermiwash in a large scale when it is required, and this is also commercially available. This is the vermiwash which is available in the bottles which you can buy. So this setup can work up to 20 to 25 days. The pebbles and the sand can be reused. There is no issue, maybe up to 1 year. But the earthworms and the decomposed compost, maximum 20 to 30 days maximum can be used, after which it has to be replaced. So the whole setup, once it is done, for almost a month, 20 to 25 days, this unit can function and vermiwash can be collected. After 25 days, the earthworms and the decomposed material and the organic waste has to be removed, and the fresh material has to be added, and the process will continue. So this is the process of how vermiwash is collected in a large scale. I will move on with this to a small scale production, what we are doing at Yenepoya University. Because at Yenepoya University, we are mainly targeting every individual to do vermicomposting. Organic matter is generated in every house. So we have small units encouraging everyone to do the composting process. So how everyone at home, not just the farmers, at home also can generate vermiwash. In this unit, you can see in the first image where this is the vermicomposting unit. At the base of the unit, you have an outlet. So through this also a liquid can be collected, but this is the vermicompost leachate, which is collected through this process. And this is a vermicompost unit where we have a bucket at the bottom of which we have connected it to a tap. And inside this, we place this unit. This is a perforated plate which you can place inside this, as you can see here. And on this plate, you will be adding the compost and the earthworms. To this, we will be sprinkling the lukewarm water. This is the again heat stress method. Lukewarm water will be sprayed onto this compost and the earthworm. Even a little bit of cow dung will be added. And this unit will filter through these perforations the liquid which is added, the water which is added on top. It will filter through these pores and it will get collected in the bucket below. and that liquid can be collected out through by the end of the day you can collect that liquid through this tap, and this is the Vermiwash which you can collect in a small scale using a small unit like this which we have at Yenepoya University. So there are various methods how Vermiwash can be prepared, whether it is vermicompost or vermiwash. One important feature which we have to notice that the raw materials which we use, that decides the quality of the compost and the vermiwash. It's a tedious process, it's a biological process. So facilitate the process. Take care of the earthworms, give all the conducive atmosphere which it requires, and the process will make wonders. And this is a very potent liquid which we collect, that is the vermiwash. How vermiwash can be used? Again, there are various methods. Vermiwash can be used as a foliar spray. It can be used as a root dip. It can also be used as a soil drench. For germination of seeds, vermiwash is very, very effective. The percentage of germination is very high. When you have to use a vermiwash as a foliar spray, for 1 liter of water, we add around 10 to 20 ml, where the dilution is very important because that is very effective, or the bioavailability of the nutrients what we have in vermiwash will be easily available for the plants. So that dilution factor also varies depending upon the strength of the vermiwash what has been prepared. When it comes to agricultural land, in 1 acre of land, almost 5 liters of vermiwash can be added. Some of them mix it along with the drip irrigation system so that it goes along with the water, and it will be continuously available for the soil, which enriches the soil. There are a lot of positive effects because of vermiwash compared to even vermicompost. Since it is in a liquid form, it is very easily available for the plants. It is also very rich in microorganisms, just like other nutrients what you have in vermicompost. And another important component is the humic acids, which is available in this. You also have the plant growth regulators, which I mentioned earlier, like the phytohormones, and this helps in altering the soil fertilization capacity, or increases the fertility of the soil. And also vermiwash is very rich in microorganisms, which also helps to bring back the microbial biodiversity in the soil. The bioavailability is very much high, as it is easily absorbable by the roots, during the flowering time. There are different stages when the vermiwash can be applied: during the stage of flowering, and also earlier to that during the seed germination, or during the fruiting time. Morning and evening the spray can be applied to the plants in large scale, or it can be also be introduced into the drip system, which will be available to all the plants in a large area. Just a comparison between the nutrient composition, and as I mentioned earlier, they are very rich in macronutrients, micronutrients. The raw material which you use for vermicomposting will be very high in CN ratio. It will be up to 30 to 40, the CN ratio. And during the composting process, microorganisms, as they are decomposing, the carbon content will be released, and you will see that the carbon content decreases, nitrogen content increases. So the CN ratio comes down almost like 10:1, which is very, very beneficial, and it shows that it is a very good compost. So micro and macronutrients both are very easily available in vermicompost. Just to show that there are a lot of studies which are available, and there are a lot of reports which are available showing the benefits of vermiwash, because as I mentioned, they contain bacteria, they contain phytohormones, they contain amino acids, the mucosal secretion of the earthworms, the vitamins, the different types of enzymes, microorganisms, micronutrients. So there are a lot of benefits by all this, which is available in one particular liquid, and which is very useful and very easy to handle, and also spray to the plants. These are some of the microorganisms which you can see in the vermicompost as well as the vermiwash: agrobacterium, astrobacter, rhizobium. You also have fungus. You have penicillium, different types of fungus. Like actinomycetes are very rich, the mycorrhizae. So these all are very essential in the soil to bring about the nutrient enrichment or for the growth of the plants. One of the important factors of vermiwash is they also help in plant defense system. They help in increasing the helping the plants to protect against the pathogens. So we have there are a lot of reports also mentioning that there are so many antimicrobial compounds which is found in vermiwash in different types of earthworms. These are all protecting the plants against the pathogens and provide immunity to the plants. How the just a small scientific information like how vermiwash helps the plants is when vermiwash is added to the plants, there will be a plant pest interaction, and that brings about secondary metabolite production. Secondary metabolites, and especially which includes the major part of the phenolic compounds, they are very much known that they help the plants to fight against pests and pathogens. And there are a lot of studies and reports to show that when vermiwash is added, the secondary metabolite production in the plants or complete plant physiology alteration takes place because of the addition of this vermiwash, which enhances the resistance capacity in the plants. Till now, I showed you the available literature which has been published where vermiwash is showing the potency for plant growth promotion. It also has a lot of microorganisms. It also has plant defense strategies or plant defense compounds. Just to show some of the studies which we have done, we have studied the metabolites in mass spectrometry analysis. We have MS1 and MS2 where aqueous extract and methanolic extract of vermiwash we have studied both positive and negative polarities, and here you will see that more than 4,500 metabolites have been identified in MS1 and more than 5,500 metabolites has been identified at MS2 level. We have also analyzed these compounds to some extent, and here are the list of compounds which we have identified. These are the class of compounds which are this is the metabolite which is identified. This is the compound which it belongs to, and these are all mainly the biological effects. When you see, these are all plant growth promoting compounds which is found in vermiwash. You also have hormones, gibberellic acid, the kinetin, the indolestic acid. These are the hormones again which help in plant growth promoting functions. These are the studies which we have done in our lab, and the compounds which we have found in the vermiwash which we have prepared in our university. As I mentioned earlier, plant defense activity, you can see here the different metabolites which have been identified with antibiotic compounds and the piperazine insecticidal properties, which help in plant defense to protect the plants against the pests and the pathogens. These are some of the field experiments we have done with vermicompost and vermiwash, where the effect of vermicompost and vermiwash has been found to be very effective. Whether it is a root nodule formation or the growth of the plants and the pods, that was cowpea. This is called winged bean. Not all the work is shown here. Some of the experiments which shows how beneficial are the plants and how positively it grew, and the effect was seen very positively in our experiments. At Yenepoya University, we also grow vegetables. As you can see here, this is our vermicomposting unit at the background, and we have different types of vegetables which we are growing here. We also have areca nut arboretum in our campus. These vegetables what we grow here, they are mainly used for food by we have 10 colleges in the university. So we have Ayurveda college, homeopathy college, we have naturopathy college and pharmacy colleges, along with medical and dental other colleges. The naturopathy college mainly requires vegetables because they prepare the patya ahara or the wholesome food, where the vegetables which are free from toxins, which are organically grown, are used, because the patients are given food daily, morning, afternoon and evening. So that diet or the vegetables which are used by the naturopathy college, they all should be free from any pesticides or chemical fertilizers. And we also have medicinal plant garden. Okay, so this is the Patyahara, where the wholesome food which is given in the naturopathy college for the patients 3 times a day. And this is our medicinal plant garden. We have Ayurveda college medicinal plant garden, the homeopathy college, even the pharmacy college have their own medicinal plant garden. The medicinal plants which are grown here are also used for production of medicines. And again, here we cannot use any chemical fertilizers or pesticides. All these are grown organically, and since it has to be used in medicine, since it has to be used in as a patient food, so it has to be completely organic. And so all those vegetables which you saw in the earlier slides are used, which is free from any toxins. The university also helps in propagating this. Now the vermicompost and the vermi wash which is prepared, it is effective to a certain extent, but value addition can always be done. A lot of farmers do the value addition by making it an enriched compost. For example, if I have to say here, vermicompost, for a quintal of vermicompost, neem cake can be added, trichoderma can be added. Trichoderma addition, you can see here, when trichoderma is added, it helps in preventing the root rot disease. Neem cake also helps in strengthening the roots of the plants, actinomycetes or phosphate solubilizing bacteria. Adding all this also enriches further the value of the vermicompost. In addition, whether potash is required or phosphate is required, depending upon what nutrient is required, value addition in an organic way can also be conducted for vermicompost, which increases the efficiency of the compost and also meets our requirements. Similarly, vermi wash also can be enriched, and the most common way of how vermi wash is used is a liter of vermi wash is usually mixed with a liter of cow's urine, and they will be both of them in 1 liter. If you take, it will be diluted with almost 10 liters of water, and that concoction is a very potent or a very effective biopesticide, an organic liquid fertilizer and an organic liquid biopesticide. Some of them have also tried vermiwash with neem oil or garlic extract, but value addition depends upon the farmers and like how they want to do the experiments with it and what are the nutrients actually what they want to do. When preparing the vermiwash and compost, as I mentioned earlier, the raw material is important. Depending upon what raw material and how much time you give for the decomposition process, not to hurry up, allow the decomposition process to happen. Vermi wash also overnight you cannot get it, allow it for the proper process to happen. Only then the nutrients will be available. They are very rich in microorganisms. For that you need to give time and allow it to happen, but value addition anyway can be done by adding any of the components which is available or what is required. The university is also responsible for sharing this knowledge. We have started this vermicomposting unit since 2014, where we have trained farmers, where we have trained women from the local area. There are a lot of education, other institutions who have visited us. So for the sake of training, we have developed this small unit. So at a household level, this unit is very functional, and these are the raw materials, and this is how we do the training process. And this is the vermi wash unit. And as you can see here, a lot of training programs are being conducted for our farmers. We also have the local women who we train, and all the trainings are provided freely. The university doesn't charge anyone, and we also support the farmers. We have even given them earthworms so that they start the process and continue it. In fact, even our faculty, there are many of our faculty who also have small farms who are also trained and supported, and continuously they take the vermicompost and vermi wash from us. And these are our units, as you can see here, where the training is being done. This is at Kudremukh Iron Ore Company, where we went and we trained the people there. We have various professors from NITK and various organizations who have visited us for the training. University has also given vermi technology as a skill-based elective subject. So under this, the students, every batch of students are trained regularly every year I think to date more than 1,300 students, because everyone does it hands-on. As you can see here, students, they hold the earthworms, they touch the compost, and you can see the whole process how they carry out here. We also have visitors from schools also. You can see the school children who come here, and they are also trained in this process. So we have taken a approach where we have encouraged everyone to do the vermicomposting and the vermiwash. We have also done experiments, and when they come to the vermicompost unit, they also get to see the vegetable garden, where we show them how the vegetables can be grown using compost and vermiwash. And we have the colleges where this organic food or the organic grown fruits and vegetables are used on a daily basis to the patients. So farmers also were very happy. We have also have outreach program where we are going now to the villages. The university has around 38 sub centers, adopted centers. So we are going using this small unit. We will be training them like how the process can be done. The farmers are at an advantage because they have a lot of raw material, and one of the important sources what they have is the cow dung, and which is very important in the vermicomposting process and the preparation of the vermiwash. So with this presentation, I would like to say that vermicompost and vermiwash is a natural method or a organic manure and organic tonic which can help the farmers in numerous ways to increase the fertility of the soil, to also to protect the environment, also to protect the health of the farmers. In the green revolution, as I mentioned earlier, the farmers' health was not taken care. We have seen a lot of cancer cases because of the use of pesticides and fertilizers in Punjab, Haryana. We also have a cancer train there. Okay. So that can be avoided. Okay, if there is a question like, can we go completely organic? I will say right now, no. We have to have an integrated approach where the farmers who are completely following the modern agricultural practices, they should try to incorporate the organic farming to the maximum extent possible. 5%, 10%, 20, 25% to whatever possible. When they incorporate organic farming into their regular agricultural practices, there will be no difficulty in getting the yield. That will be maintained as it is, but you will be reducing the burden on using the chemical fertilizers, using the pesticides. So that burden can be reduced, and you will also reclaim the soil. The soil fertility can be reduced. Soil is very precious. It's a very important natural resource. Even around 5 centimeter of soil to be formed, it will take some hundreds of years, 200, 300, 500 years it takes by the weathering process to form the soil. And to become a fertile soil, it will again take 1,000 to 2,000 years. It has to have microorganisms, organic content, humic acids, nutrients. So soil is very, very precious. And the microorganisms, what you have in the soil, they are the basis for all the food chain. So the biodiversity of underground soil is essential for the biodiversity of all the organisms above the soil. In fact, even United Nations Environment UNEP has also the entire food chain has also recognized that the below ground biodiversity is essential. We have to maintain the biodiversity of the soil if we want to have sustainable agriculture, if we want to have the economy in a sustainable way. We have to maintain the underground biodiversity, which will take some time. And that's why I said integrated approach will help the farmers. It will also take care of their health. And another issue which we will be addressing is we will be managing the organic waste. By utilizing that organic waste into a product which is very, very useful, which we already discussed. So the menace of management of organic waste can be handled, and also the impact which it has on the environment by release of the methane, that also can be handled. It's also a source of lot of diseases. So composting, vermicomposting and vermiwash is like a one-stop solution where we can address a huge number of issues. Since this is mainly for the farmers, but everyone at home also can do vermicomposting and vermiwash, which is good for us, good for the soil, good for the environment, and good for our country. Sir, with this, I would like to conclude my presentation. Earthworms, they are nature's humble heroes and farmers' friends. Thank you. Sir, you're muted.
Thank you, madam. It is a very nice presentation. It is like a heavy downpour which has happened today, and from a complete value chain. And this is what is expected out of this webinar. This is, that 1 hour, 1.5 hours, the address talk. It gives a total value chain for a researcher, a student, or a farmer, or other users to understand. And that, I think, and I should thank you for giving a complete talk. And it is like a one-stop solution. In vermicompost and vermiwash is a one-stop solution, and this webinar has given a one-stop solution for all the community to utilize that. Thank you very much. Mr. Manish, can you publish the any feedback which we received, or can you put Professor Mahendesh Patel if he is there, or Professor Mary Josephine, and also the farmers who are already joined. I welcome Professor Mahendesh Patel and Professor Mary Josephine. Can you put your video on, and also Center for Environment, and Madam Dr. Geeta. Welcome. And Professor Mahendesh Patel, you can adjust your camera. You can adjust your camera. It has gone to one side. Okay. Very nice. That very nice. That can you put Center for Environmental Studies and Dr. Geeta to put your video on. I welcome Professor Mary Josephine. Because of her only, she only recommended Dr. Bhagya Sharma to address this webinar series to make it enriched, and also to
Thank you, sir.
increase its credit. And I'm very happy that it has increased its value in the national and international webinar. Thank you very much. And
Thank you,
can
sir.
Dr. Geeta also, can you put your video on? Okay, thank you, madam. And now we had, even though I had, traffic problems, I was able to reach only at 20 minutes late, but we were able to have the program from 11:20 onwards and till now, and it is a very meaningful program for the journey which the University Shobhit Institute of Engineering and Technology has taken for the last since 2010. There is agriculture informatics discipline as the main core through 5 centers of excellence. Now, as a part of the Doubling Farmers Income Committee report, we were involved and for the digital technology in agriculture. By today, it is it is 131 webinars in this series and 118 webinar in the other series, international webinar series. It means that it's 249 webinar topics, means 249 agri-tech startups can come in one particular district. So you can multiply, like earthworm gets multiplied, 250 startups into 800 districts. How much help can come with the help of educational institutions to help our farming community? Today topic is very important, and I would like to hear from the Professor Mahendesh Patil and Professor Mary Josephine that what is the message which Dr. Bhakti Sharma has given to the farming community, especially small and marginal farming community, and also the developing nations where agriculture is the primary economy. Over to Professor Mahendesh Patil briefly.
Thank you, sir. Am I audible, sir?
Yes, yes.
Thank you. So, good afternoon, everybody, especially Professor Bhagya Sharma and others. Uh, Morning only, sir, in Clubhouse, we had a very good interaction on academia industry interface. So, today's topic by Professor Bhagya Sharma, it fits in 100%. Because the lecture and the works and the preparations what they have done through their university, it is just systemic and systematic. Even although from agriculture university and faculty from plant pathology, I have not seen the preparations like in the especially vermicompost division of our university. Such a level they did it. It is just wonderful, and really, madam, I appreciate your knowledge and your efforts
Thank
and
you so
taking
much.
into consideration the each and every even small pieces of information. See, in making that very delicate animal or invertebrate into a very see of golden standard, isn't it? So that the care you have taken while preparing the solutions and understanding its biology and its exposure to the environment, even at the farmers level or at the management level, that is of great importance. This is actually what is required, sir. As you as you said, I used to say it is not a webinar series; it is a web series on the science and technology. Okay, if you convert them into commercial web series, definitely you are going to become millionaire or billionaire. I
No,
don't
no,
know, but
I actually,
unfortunately,
just 1 minute. I have not done it. I thought that I was meaningful and I should be meaningful till my last breath. But with your support, we'll bring, that wealth generation also for our farming community. We will pay back to the farming community. Over to you.
true,
Yes.
sir. Yes, sir. Actually, I call always wash as a cocktail. You know, a cocktail of nutrients, defense molecules, and the antimicrobial molecules, so whatnot. So everything is there. Only thing is, which I used to say, which what is sustainability? Okay, which we have to keep those things sustainable, which keep us sustainable. That is the mantra of sustainability. Otherwise we find a lot of dialogues, so many gurus are there in saying sustainability, but no one goes in depth. Okay, no one tries to deep delve into the issue and get the very simplicity of that the overall exercise. So but today I find with Professor Bhagya Sharma madam is really, and I also appreciate and I also congratulate their university for having her as a deputy director there. Because what I feel is with this work now, many farmers and farmer families, especially women part of the family, okay, if you make them enable with this kind of exercises, uh, I think again what Atmanirbhar Bharat, definitely one day it will happen. Until unless we promote the women in the farming family, we cannot achieve anything, sir. This is my personal experience. So for her we have to make this kind of the leveraging her to this kind of technologies, the simple one and a very delicate one. Man cannot handle the delicate issues in the family. Women are meant for it. Okay, it is a child or it is a family relationship or anything, or the very what you say, the crucial relationships. So here, vermi wash, vermi compost, vermi worms as a whole, definitely they come for rescue. Like this other parts of the organic practices are there, Jivamruta is there. So everything is our livestock based. Okay, whether it's a cow, buffalo, or whatever it is there. So that is very good, say, consortia of say supporting the farmer family and as well as our farmland. Actually, what is organic? See, we talk so many things in today's organic. Just not putting organic substitution to farm, it's not organic. Organic is giving life to the non-living things, it's organic. So for that, we must be organic. The workforce should be organic. Our think process should be organic, and our approach should be organic. Then only it becomes organic. So sometimes, madam, I take backseat while saying organic is not possible, and let us join the inorganic with the organic. Somehow, I feel as a plant pathologist or from microbiological field, I hardly support that thinking. Because see, when you are applying the chemicals in the form of fertilizers or any other biostimulants, especially the inorganic chemicals, definitely one or the other way it is going to affect the life of the soil, that is the microorganisms. Until unless we strengthen them, we encapsulate them with any technology, so we are going to lose our microbes. The same way on the leaf side or the stem side or the fruit side, whatever we call the habitats are there, either it is on the dorsal side or the ventral side or even in the tissue. Definitely, I have seen with the especially the VD sides, herbicides, the most down to earth chemicals we call in chemistry, because they can take care of anybody, including farmer. Such a level they are very harsh. Herbicide, VD sides, when they get sprayed to the weed, of course, with the management defects, it gets spread into the other parts of the plant, even normal food crop or horticulture crop. Automatically, one or the other way, it will have its effect on the microbes which are prevailing over there, either in the air, water, soil, or the plant surface. So this way, what I say is, if you want to do organic, you should forget everything, just do organic. That's all. By all the, you should create system of organics and continue it. Let us not compromise with the chemicals way of farming. Let us not blend them. Okay, if you are doing chemical, don't bother about all organics and other these satwa gitwa principle. Do inorganic and get the things, okay, and sell it and get the money and enjoy. So this way, okay, if people say natural farming means, see, everything should be natural. Okay, the system should prevail over, then only natural things will happen. But in commercial agriculture, this natural farming will not do, because agriculture means it is an engagement with the nature. So agriculture means it's a food factory, just like a kitchen. Okay, when a mother or wife or a sister does work in the kitchen, they take one basic material like rice, then they go on adding all other things to that to make it a food. So this way, soil, seed, and the environment, it depends on how do you get involved into that. So in this way, as you told, it is fine. Vermi compost, they are the our resources, okay, our treasury, and we do have almost 200, more than 200 species must be there in India compared to Africa, and we do have very special South Indian worms. What I have heard from my friends compared to North Indian. So South Indian worms, just like South Indian people, they are very special people. Like so, worms are also there. So this way, what I feel, definitely these vermicomposts are one day or other, these kind of the parallel or these complementary practices of farming, definitely they will take upper hand over the inorganics. That is, the day will come. Okay, already it has come. People like Bhagya madam and others who are into urbanizing the food with the organics. That is very important. Okay, they are convincing and they are enabling the mediators. That is excellent part, sir. So thank you very much for giving and inviting me to this. I I used to go for the archives of all the Shobhit University's webinars, but today you made me to sit and hear to Bhagya madam. It's excellent, sir. Definitely, since I'm in Karnataka, one day I will go to Mangaluru and visit her lab and the university. More interest now has gained me, and definitely I will take my friends and the farmers to visit there. Anyhow, I have my own academy, and definitely I will make it, sir. Thank you once
Thank
again.
you thank you. I'm audible. Thank you very much, Professor Mahendesh Patil. We are, we are making our journey not now. It is from 2008, and you are not only at the back seater. You are not watching. You are also part of this web. So and when the technology was not available at that time, and it is very important that people like you to participate and give the importance of the webinar, because as you said it, when I started this webinar series, I think if every professor in every higher education institution started the journey like what Professor Moni has done it as a hardcore technocrat, I think we don't need a district administration for development. They need administration for law and order, health, and judiciary only, and civic services when there is a flood or other things that. But for development administration for agriculture, animal husbandry, fisheries, and food systems, we need higher education institution and NGOs and the farming community. They can do wonders. And this support should be made available 24/7 environment. And I'm also, and I'm very happy that people like you, took voluntary retirement. Now you started your own academy. And there is a big support for me to bring in that. I'm not from the, biology side. I'm not from agriculture science, but I'm from completely on informatics, which I'm trying to create a web in all the things. Professor Swaminathan's time is green revolution, but I am promoting green revolution, that is GRIN, genomics, robotics, informatics, and knowledge. So every science, it is not only what All India Council of Technical Education talk about STEM. It is science, technology, engineering, mathematics, but I want to make it as a STEAM. STEAM. Science, technology, engineering, agriculture, and mathematics. And agriculture and management. Arts and mathematics, arts and management. The STEAM is very important. Starts with agriculture and ag, and M is mathematics and management. If these two things are not there, and if agriculture, digitalization of agriculture and rural management alone will give that $5 trillion economy, which we are not utilizing. Our resource management at the grassroots level is gone for a toss. Nobody bothers about it. The project which we initiated under the doubling farmers' income, smart tribal farming, it is wakening up many people. Now I'm very happy that the higher education institution is now trying to establish my concept of Center for Agricultural Informatics and E-Governance Studies, which this university has got, is the first university in the whole world to have it. And this webinar 2, Center for Excellence, which I established it, is doing wonders in bringing that, you said it, that in a national, international web of scientists and technocrats and administrators and farming community. This is what has to happen in every higher educational institution, whether they teach agriculture or not, but they are teaching physics, they are teaching chemistry, they are teaching biology, they are teaching mathematics, and they are teaching economics, they are meeting geography, they are teaching history. When they teach all those things, then it means that India being an agrarian economy, it comes down to the village. Thank you very much. Now we would like to hear from Professor Mary Josephine, because now she has become a biggest strength for me to promote these centers of excellence in many colleges. And she identified Professor Bhagya Sharma, and she also tweeted that the right person has joined with the right person. I don't know here the right person, who is the right person and who is the other right person. But that's what Professor Bhagya Sharma, today morning, she put it in my WhatsApp message. After seeing this, right person has joined with the right person. Over to you, madam.
Thank you, sir, for this wonderful words. Good afternoon, everyone. First of all, I noted many doubts regarding the presentation, and she covered from top to bottom everything. So I have only few doubts. First of all, I like to thank Professor Moni sir and Dr. Bhagya Sharma. Immediately he arranged international webinar. That meeting reach almost all farmers. It should reach. If we open a center of a vermicompost unit and giving training to all the farmers instead of going for organic, because this vermicompost is we are doing, but vermiwash that reach the plant root immediately. It's like when we put drips, like drips of glucose, instead of taking food that directly react. This vermiwash is like that. It enters through root immediately, it pass on and promote the growth rate of plants, and it acts like a biocontrol. There is no need of spraying pesticides or fungicides or bactericides, because this itself acts as a fertilizer, biofertilizer, and also promote the growth rate and control the diseases. So biocontrol agent. And one point I noted, without a cow dung, it is impossible. In some areas, there is no dung is available. In that area, we can supply this vermiwash and vermicompost as a market product. We can get income if we promote this, and we can export also, because many countries, they are not patient, as he mentioned. Only women can do, only our Indian women can do such hard work. This vermiwash is not an overnight product. So they do patiently and produce this vermiwash and vermicompost fertilizer. If all farmers they do started doing this vermicompost and vermiwash, we'll get our motherland, as we say 10, 20 years back, because this earthworm also supports other soil fertilizer and promote the growth and soil microbes, beneficial organism. Professor Moni sir, he used to tell in almost all the meeting, soil health, plant health. So this cover both soil health and plant health. So this webinar should reach all the farmers, especially first we put in practice in India, and we can see the result after 5 years. If we are not using, as he mentioned, one either go for fully organic or either go for inorganic. As he mentioned correctly, if we go for organic fully, we'll get our motherland immediately. Only thing, we have to produce in bulk. Yeah, all waste we can convert it to this product, waste product, organic waste only. And he mentioned only onion peel and garlic peel we are not using. You can segregate those onion peel and onion peel with eggshell. It's a very good fertilizer for rose and other crops. And we have to check it whether this is useful for all the crops, at what stage we have to add it. And you mentioned this speed up the germination rate. So we have to check that also. If we grow very fast, some seeds that especially pulses, that will take more time to germinate. If we treat those seeds, this germinate very fast. So this webinar is really, it's like, I don't know what to say, don't find any words. If it reach, we can reach the top of the mountain. All our images, especially Professor Moni sir, he used to tell, he is working hard 24 hours, 24 into 7, round the clock, anytime. After 12 o'clock or so, if we message, immediately he reply. And he keeps everything in his brain. I don't know the way computer is discovered and other things. I don't know what memory storage chips he is having in his brain at this age. That is my always I think about that, how he is keeping all seminars, all people, and all topics what they discussed. I don't know what chip he is using. Thank you a lot for
Thank you,
giving
madam.
this wonderful
Thank you.
opportunity
Thank
to
you. Thank
give
you.
the feedback. Yes.
Thank you. That I get always health and tonic by interacting with all of you. That is very important. That
Thank you,
my
sir.
not only now, I always still remember that today I'm here is because of my primary school teacher, secondary school teacher, higher secondary school teacher, my college teachers, and my scientific community with whom I worked, and they have made my my dream, visionary dream, successful. When I was given the district level programs in 1987, I will give you 1 minute for the benefits of other two scientists. I was given district information system of NIC 6-letter word by my boss in 1987 to introduce computerization. And he said that you are an IITian and you give flesh, brain, leg, everything, you make a shape. And I brought out by interacting with the various areas, I was able to come out with the 28 sectoral database development program. And that time itself, 87, when we didn't have even appropriate meaningful database technology products, only DBase and Foxbase. And if the database parameters which we discussed on that time, I don't know how I brought it. Only thing which I did is I was born and brought up in rural area. We've seen poverty in life, and now it is an opportunity has been given for technology adoption. Let me do it rather than for government department, but for the rural area. That's how many things I was able to bring it out. Many people used to tell me, you are not a IAS officer, you are a technocrat, how you are able to bring out so many schemes. I think what you need is we should have your heart to work for rural area, and then many things will come out. and this is how I'm very happy. And now the journey is that how to network with the 45,000 engineering colleges, computer science discipline, and 45,000 non-engineering colleges who teach sciences, and then 1,500 deemed to be universities, to bring in revolution at the grassroots level through 4 areas: genomics, robotics, and informatics and nanotechnology. I think each webinar is providing a strong basis for our 6.5 lakh villages, and so many institutions, and every institution gets students from rural area. They will become an ambassador. And the example which Yenepoya University has done, I strongly feel after listening to Professor Mahantis Patil and Professor Mary Josephine, this center should be recognized by Government of India as a national center, for propagating not only in India. We will also this through this Center for Agriculture Informatics and Agribusiness Disaster Management Studies, we will also take this. Our university has signed an MOU with ARDO, African Asian Rural Development Organization, 32 member countries, which has got headquarters in Delhi. We will also take this technology to the 33 member countries, 18 African countries, and 15 Asian countries, including India. Is a very much potential. Every institute should become a national university. University means Vishwa Vidyalaya. That's what that myself and my chancellor used to say, that our program should be at least throughout India. That's why many programs we are doing it. Let us not, even IITs don't even bother about it. For them, other campus is America, not India. And so we thought that Vishwa Vidyalaya means at least India should be our our world, and we should do that. Let us do this through informatics, get on to the agricultural economy through technology. Thank you very much. Now let us hear from Dr. Geeta, and you have is an alumna of Mahi is that Mahi, where she has completed her BSc and MS in biotechnology. She did her PhD from Yenepoya University on plant biology. Madam, over to you. What did you hear, and what is your contribution, and how you would like to take further to the small and marginal farmers? Dr. Kidaji. Your voice is not audible. Hello?
Okay.
Kindly speak.
So I have done a short study during my PhD period. Am I audible there, sir?
Yes, yes.
Am I audible there, sir?
Yeah, audible. Please speak. You speak, madam. Okay. Meanwhile,
Can you hear
please
me,
speak.
sir?
Yeah, please speak.
We can hear you.
Okay. Let us hear from from Center for Environmental Studies, Mr. Ajit. Hello. Can you unmute? There is a problem from Dr. Geeta's
So
side.
he is,
We are not able to.
we have Mr. Praveen, who is a hospital
Mr. Praveen.
superintendent.
Yeah. Mr. Praveen.
Okay. Okay, thank you, ma'am. So I have done a short study along with my PhD study where I've tested the effect of vermicompost.
We are not able to hear you, madam.
Dr. Geeta, we will come back to you later. We will continue with Center for Environmental Studies now.
Good afternoon, sir.
Good afternoon.
Sir. My name is Praveen Kumar. I am working in Yenepoya Medical College Hospital as a hospital superintendent last 27 years. ಇಸ್ ಅವರ್ ವರ್ಮಿ ಕಂಪೋಸ್ಟ್ ಯೂನಿಟ್. ಲಾಸ್ಟ್ 10 ವರ್ಷದಿಂದ ನಾವು ಮಾಡ್ತಾ ಇದ್ದೇವೆ ಸರ್. ಇಲ್ಲಿ ಅದರ ಮೇಲ್ವಿಚಾರಕರಾಗಿ ನಾನು ಕಾರ್ಯವಹಿಸ್ತಾ ಇದ್ದೇನೆ. ನಮ್ಮ ವರ್ಮಿ ಕಂಪೋಸ್ಟ್ ಅಲ್ಲಿ 6 ಯೂನಿಟ್ ಇದೆ, 6 ಯೂನಿಟ್ಸ್. ಈಚ್ ಯೂನಿಟ್ ಕೆಪಾಸಿಟಿ ಅರೌಂಡ್ 250 kgs ಇನ್ 3 cycles. ಸೊ ಮಾಡೋ ಉದ್ದೇಶ ಏನಂತ ಹೇಳಿದ್ರೆ, ನಮ್ಮ ಕ್ಯಾಂಪಸಲ್ಲಿ ಸಿಕ್ಕುವಂಥ ತರಗೆಲೆಗಳಿಂದ ಹಾಗೂ ತರಕಾರಿಗಳಿಂದ ನಾವು ಈ ಒಂದು ವರ್ಮಿ ಕಂಪೋಸ್ಟನ್ನು ಸ್ಟಾರ್ಟ್ ಮಾಡಿದ್ದೇವೆ. ಸೊ 10 ವರ್ಷದಿಂದ ಬರ್ತಾ ಇದ್ದೇವೆ. ಈಗ ಒಳ್ಳೆ ರಿಸಲ್ಟ್ ಬರ್ತಾ ಉಂಟು ನಮಗೆ, ಒಳ್ಳೆ ಗೊಬ್ಬರ ಸಿಗ್ತಾ ಉಂಟು ನಮಗೆ ಅದರಿಂದ. ಸೊ ಫಸ್ಟಾಗಿ ನಾವು ಈ ಗೊಬ್ಬರವನ್ನು ನಮ್ಮ ಸಿಬ್ಬಂದಿಗಳಿಗೆ, ನಮ್ಮ ಆಸ್ಪತ್ರೆಯ ಅಥವಾ ನಮ್ಮ ಯೂನಿವರ್ಸಿಟಿಯ ಸ್ಟಾಫ್ಗಳಿಗೆ, ಡಾಕ್ಟರ್ಗಳಿಗೆ ಎಲ್ಲರಿಗೂ ನಾವು ಇದನ್ನು ಕೊಟ್ಟಾಗ ಒಳ್ಳೆ ಪ್ರತಿಫಲ ಬಂದು ಇದನ್ನು ನಾವು ಒಂದು ಒಳ್ಳೆ ರೀತಿ ಮುಂದುವರಿಸಲಿಕ್ಕೆ ಪ್ರಯತ್ನ ಪಟ್ಟಿದ್ದೇವೆ. ಹಾಗೆ ಇದು 10 ವರ್ಷದಿಂದ ಚೆನ್ನಾಗಿ ಒಳ್ಳೆಯ ರೀತಿಯಲ್ಲಿ ಬರ್ತಾ ಇದೆ. ಈ ಒಂದು ಗೊಬ್ಬರದಿಂದ ನಮಗೆ ತುಂಬ ಮಹತ್ವವಾಗಿ ನಮ್ಮ ಕ್ಯಾಂಪಸ್ಸಲ್ಲಿ ಈ ಗೊಬ್ಬರವನ್ನು ನಾವು ಎಲ್ಲ ಕಡೆ ಯೂಸ್ ಮಾಡಿದ್ದೆವು. ನಮ್ಮದೇ ಆದ ತೋಟ ಇದೆ ನಮ್ಮ ಯೆನೆಪೊಯದಲ್ಲಿ. ಅಲ್ಲಿ ಹಾಕಿದಾಗ ಒಳ್ಳೆ ರೀತಿಯ ರಿಸಲ್ಟ್ ಬಂದಿದೆ ನಮಗೆ, ತರಕಾರಿಗಳಿಗೆ ಆಗಲಿ ಬೇರೆಗಳಿಂದ. ಹಾಗೆ ನಾವು ಇದನ್ನು ಪರ್ಸನಲ್ ಆಗಿ ನಾನು ಮಣ್ಣಲ್ಲಿ ಯೂಸ್ ಮಾಡಿದಾಗ ನನಗೆ ನನ್ನ ತರಕಾರಿಯಲ್ಲಿ ವ್ಯತ್ಯಾಸ ಕಂಡು ಬಂದಿದೆ. ಹಾಗೆ ರುಚಿಕಟ್ಟಾದಂಥ ಒಂದು ತರಕಾರಿಗಳು ಸಿಕ್ಕಿದೆ. ಇದರ ಮೂಲ ಉದ್ದೇಶ ಅಂತಂದರೆ ನಮ್ಮ ನೆಲದಲ್ಲಿ ಮಣ್ಣು ನಾವು ಕೆಮಿಕಲ್ ಹಾಕಿದಾಗ ಎಷ್ಟು ಹಾಳಾಗ್ತದೆ, ಅದೇ ರೀತಿ ನಾವು ಈ ಗೊಬ್ಬರ ಹಾಕಿದಾಗ ನಮ್ಮ ಈ ನೆಲ ಸಹ ನಮಗೆ ಮುಂದೆ ಒಳ್ಳೆಯ ಒಂದು ಕ್ರಿಮಿನಾಶಕ ಇಲ್ಲದೆ ನಮಗೆ ಒಳ್ಳೆಯ ಸಾಯಿಲ್ ಸಿಕ್ಕಿದೆ. ಹಾಗೆ ನಾವು ನಮ್ಮ ಈ ವರ್ಮಿ ಕಂಪೋಸ್ಟನ್ನು ನಾವು ಬೇರೆ ಒಳ್ಳೆ ಡಿಮಾಂಡ್ ಬಂದಿಂದ ನಾವು ಬೇರೆ ಕಡೆ ಸಹ ನಾವು ಮಾಡ್ತಾ ಇದ್ದೇವೆ. ಇದರಿಂದ ಒಳ್ಳೆ ರಿಸಲ್ಟ್ ಸಿಕ್ಕಿದೆ ನಮಗೆ, ಒಳ್ಳೆ ಡಿಮಾಂಡು ಇದೆ ಈಗ. ಹಾಗಾಗಿ ಇದೊಂದು ಒಳ್ಳೆ ರೀತಿಯಂತ ನಮ್ಮ ಒಂದು ಸಮಾಜಕ್ಕೆ ಇದೊಂದು ಒಳ್ಳೆ ರೀತಿಯಂತ ಗೊಬ್ಬರ ಹಿಡಿದು ಇಷ್ಟಪಡ್ತೇನೆ ಈ ವರ್ಮಿ ಕಂಪೋಸ್ಟ್. ಇದು ಮುಂದೆ ನಾವು ಇದನ್ನು ಸಹ ನಾವು ಬೇರೆ ಪ್ಲಾಂಟ್ ಮಾಡಿ ನಾವು ಪ್ರಯತ್ನ ಪಡ್ತಾ ಇದ್ದೇವೆ. ಹಾಗೆ ನಾವು ಬೇರೆ ನಮ್ಮ ಸ್ಟಾಫ್ಗಳಿಗೆ ಟ್ರೈನಿಂಗ್ ಕೊಟ್ಟು ಅವರವರ ಮನೆಯಲ್ಲಿ ಮಾಡಲಿಕ್ಕೆ ಸಹ ನಾವು ಪ್ರಯತ್ನ ಪಡ್ತಾ ಇದ್ದೇವೆ ಈಗ. ಹಾಗಾಗಿ ಬೇರೆ ಸ್ವಾರ್ಥ ಸಂಘಟನೆಗೆ ವಿಮೆನ್ಸ್ ಅಂತ ಒಂದು ಕಟ್ಟಿದವರಿಂದ ನಾವು ಈ ಒಂದು ಪ್ರಯತ್ನ ಪಡ್ತಾ ಇದ್ದೇವೆ. ಇದರಿಂದಾಗಿ ಈ ಒಂದು ವರ್ಮಿ ಕಂಪೋಸ್ಟಿಂದ ನಾವು ಒಳ್ಳೆಯಾದಂಥ ಒಂದು ಫುಡ್ಡನ್ನು ನಾವು ಪ್ರಯತ್ನ ಪಡ್ಬೋದು. ನಮ್ಮ ಒಂದು ಪರಿಸರಕ್ಕೆ ಸಹ ಒಳ್ಳೆಯ ಒಂದು ಸಂದೇಶ ಹೇಳಲಿಕ್ಕೆ ಇಷ್ಟಪಡ್ತಿದ್ದೇನೆ. ಥ್ಯಾಂಕ್ ಯು ಸರ್.
Thank you very much, Mr. Praveen. Madam, Dr. Bhagya, can you translate in English that some
it was in Kannada, sir.
Somebody? Yeah, that's
Mr. Praveen, he is our hospital superintendent. He just said that Yenepoya University since 2014 has started with the vermicompost unit, where our main objective was to handle the organic waste of the campus, since we also have a central kitchen and a huge quantity of waste is being generated. We also started with the training programs, and we saw that a lot of doctors, and actually we are happy that because whatever the doctors say, if they say this is good, people will follow. And we were happy that a lot of people came for our training, and we have regularly a lot of people, scientists. We have a research center, we have scientists and doctors who buy the vermicompost and vermiwash from us. And Mr. Praveen is one. He has a garden where he grows vegetables, and he regularly takes our vermicompost, and he mentioned that it was very good, and he found that the plants were very healthy and it was effective. That's what he said.
Nice. It's very nice that after listening to him, and why don't we have one video started from as a superintendent of the hospital and also a farmer, then you cross back, throws the light from his farm using the vermiwash, and as a superintendent of the hospital, and then maintain kitchen here, and then how the food is being prepared, and then getting into the scientific work which the Yenepoya University is doing it, and then ending with various there's bites. And it will be very nice to have a video with the subtitling both in Kannada and English. It will be very nice that, madam, this is my requirement, because from university to a farmer level, and that also is a very important connect. As a farmer, he does it, and then as a superintendent, and the hospital uses the complete waste which is being generated from 10 colleges, and it gets certified. And then another one which you put it your College of Naturopathy, it uses for their food preparation the vegetables which are grown only within the campus. It is a big organic certification. We don't need it to have certified bodies which are approved by the European countries. So this is very important. We also would like to tell, some of my my well-wishers used to say, when I was in when I used to do so many things, they said, and that time I was a deputy director general, that secretary IT was telling, Moni, you should go to the rooftop and cry that I'm doing it, shout that I'm doing it. India should do like that. We should go to the rooftop, like if cock has to do kukurako, it doesn't do it on the ground. It goes to the rooftop. It goes to the rooftop and then tell that kukurako. So it is what we should do. That I'll be very happy that if you make a video starting from his farm, and then how university, hospitals, and then this organic waste, and then what is a strong sound science and technology and innovation support which is being given by the university or established by the university on and Professor Mahendesh Patil said it, sustainability is what? That is that keep sustainable. This is what you are doing it, and this is that let us have this one as a video. Now, Dr. Geeta, are you ready to give your comment? Dr. Geeta, hello. Okay, and can you unmute your mic? Very nice that and it's a very good presentation and address and very important talk which we had it. We convert, as you said it.
Hello?
It is yes, Dr.
Am I
Geeta.
audible there, sir?
Audible, madam. Now it is good. Please speak.
Can you hear me, sir?
Yes, madam. Please speak.
Okay.
No, we are not getting.
So
We are not getting your voice.
tested effect of vermicompost on growth
Dr.
and
Geeta.
productivity of. Sorry,
Dr.
sir.
Geeta, please use your only audio.
Please use audio.
Keep the
Now,
video off so that only audio. It will be better. Keep the video off.
Yes. Okay. Yeah.
Please speak.
Okay.
Yeah, now speak.
Can you hear me now, sir?
Yes, yes.
Okay, I have tested the effect of vermicompost on growth of two edible legumes, that is cowpea and winged bean. Here I had taken soil as a control, and vermicompost along with soil in the ratio of 1:3 was taken as experimental growth. The growth parameters such as germination, removal emergence, root nodule, plant height, number of leaves were found to be more in vermicompost grown plants compared to the soil grown plants. Also, the productivity parameters like flower, pod number, pod length, it was high in vermicompost grown plants. And we have observed that plants grown in vermicompost bin were disease free, whereas in the control we have seen yellowing of leaves and early premature death of plants. Also, the physicochemical parameters like NPK, nitrogen, phosphorus, potassium, moisture content, water holding capacity was better than the control. So, the soil incorporated with vermicompost had increased the soil fertility and the growth of crops we have tested. So that was about my study. It was a short study along with my PhD study. I had done this in Yenepoya.
Yeah. Hello.
Hello,
Okay.
sir.
Yeah. Please. Your voice is not coming. Okay. Okay. Very nice. That
Poor
it's
network connection here, sir. Sorry.
Yeah, okay, no problem. What you can do is that you can to include in the proceedings, you can send your comments, so that it can be included. I think Dr. Bhagya Sarmaji
Yeah.
can get her comments and we will include, and also that Dr. Mr. Ajiz, Praveen's his comment, what he said it, so that it can be included in the our workshop or webinar proceedings. So I think it is a time that it has gone for 2 hours and 5 minutes, and it is a very important topic, and it is joined by, apart from our guest speaker, Dr. Bhakya Sharmaji, and joined by Professor Mahendesh Patil and Professor Mary Josephine, and the superintendent of the hospitals of Yenepoya University, and Madam Dr. Geetha. It is very important conference which we have done it, and this should go. The message should go to the farming community very effectively, and also every higher education institution should see this as an example. For example, apart from the university, so with university, their biomedical engineering department is very strong. Like that, now we heard from Yenepoya University that what Professor Dr. Bhakya is doing, Center for Earth Sciences Environmental Studies, is doing wonderful job. So if every higher education institution started putting their what they've done it, if the country comes to know about it through this national webinar and international webinar, I think that India can become a world leader. What we have to achieve is that German has brought industry 4.0, Japan has brought society 5.0, India has to give agriculture 4.0 to the whole world. This is what it's important, that because India should become an anatata to the whole world. We have 127 agroclimatic zone, 365 days of sunshine. Our rainfall is much more than what Israel has it, and then we have more than 400 agriculture commodities, centuries old, our farming methods, and even we have taken a pilot project on smart tribal farming, and we are looking into the tribal areas. It's fantastic agricultural land they have it. Their land agricultural land is not even disturbed by many other chemical fertilizers and so on and so forth, but the realization by district administration is very poor. They are restricted with respect to the tribals only with respect to their handlooms and handicrafts and their traditional dance. And they said that for food they will depend upon the public distribution system and Mahatma Gandhi rural employment guarantee scheme. Other things that this is more than sufficient, that but they can there is a sustainable agriculture, and they know their eco botanical characteristics which they have it, veterinary practices, many things which they have it. It has to be documented, and they should have the appropriate IPRs and so on and so forth. So digital technology in agriculture can bring wonders, and we should do it. And every farm and farmer has to be a model farmer and model farm, smart farmer and smart farming. And this is what the university has undertaken. And if Yenepoya University and Shobhit deemed to be, Institute of Engineering Technology and Shobhit University join together, and like that, every deemed to be university join together. I'm not talking about the public sector universities. They work in a different manner, but the private universities have got a common goal. And for development at the grassroots level, let us move ahead and bring in revolution through this genomics and robotics and informatics and nanotechnology at the grassroots level. Thank you very much for joining today's webinar. And this is a very important webinar. I would like to thank the our Honorable Chancellor, Honorable Vice Chancellor, and faculty members, and our guest speaker, Dr. Bhagya Sharma ji, and and uh, and then Professor Mahantesh Patel, Professor Mary Josephine, Dr. Geeta, and the participants from India and abroad for joining this program and for its success and very important webinar. And I'm very happy that we're able to organize effectively. Thank you for your participation and greetings from Shobhit University and Shobhit Institute of Engineering and Technology. And for more research inquiries, please contact Professor Moni, Professor Emeritus and Chairman, Center for Agricultural Informatics and E-Government Research Studies, Center for Agribusiness and Disaster Management Studies, Center for Informatics Development Solutions and Application, Center for Industry 4.0 Technology Studies and Application, Center for Health Informatics and Computing. Have a nice day. Thank you very much. Next, we will see you next webinar.